So this question here is question number 16 from exercise 1, alcohol phenol ethers of phase 5 book. So we have a question which explains about different conditions here. So find the structure of A. Our question is very simple. Structure of A with the formula C₁H₁O₂. Again, C₁H₁O₂. So that means it's a highly unsaturated compound. So we need to understand how many rings are present, how many double bonds are present and all. So we have taken the degree of unsaturation here. So when we substitute the number of carbons, the formula, as you already know, it's the 2 times of number of carbons plus 2 minus of number of hydrogens divided by 2. So 2 into 10 plus 2 by 2 and minus 10. We are going to get a degree of unsaturation of 6. So since the degree of unsaturation is so high, so we can assume that there should be a benzene ring available. So benzene ring accounts for how many degree of unsaturation? 4. So in this, 4 of them are taken for benzene ring, let's say. Benzene ring, then we have to account for 2 of them. And then the 2 of them, when we take, according to the next statements, based on the next statements, it does not dissolve in NaOH or give color with FeCl₃. That means it is not going to be the phenolic group, because it does not show any color with FeCl₃. So phenolic group is absent. It cannot be shown. Next statement says it adds one equivalent of hydrogen. What does that account for? That accounts for one carbon double bond. One carbon double bond. So beyond that, we are assuming that one more ring should be present. So one additional ring can be present along with the benzene ring. That's a conclusion for the degree of unsaturation, what we can take into consideration here. So taking this point, we are going to identify how the reaction can proceed. Now, where from we have to start? Obviously, we have to start from the last part. The last part says that there is a compound C which on reflux and reaction with HI. Reaction with HI is giving an 2 OH groups here along with a COOH group. So based on that criteria, the most feasible structure of A can be what? It should have an benzene ring. It should have a benzene ring and has its side chain which has a double bond, CH double bond CH2. Now we need to account for the rest of the oxygens also. So the assumption is an diether, cyclic diether. Why a cyclic diether? Because here the reaction is with concentrated HI, which is usually observed for the acetals. It is reaction for the acetals. We have learned in the alcohols, phenol ethers that whenever there is an ether, if you remember, an ethereal bond, NOR bond reacts with HI to form what? It forms an alcohol and an alkyl halide. So based on that conclusion only, we can make this statement that our compound has a cyclic diether here. So let's see whether it will account for the reactivity or not. So first of all, since the side chain has a double bond, carbon double bond, it is going to undergo reduction in presence of 1 mole of hydrogen. So the product here, due to hydrogenation, what we can write is CH2, CH2, CH3. So yes, this reaction is possible for this compound because 1 of the mole of hydrogen has been added up in the double bonded molecule. Now coming to the ozonolysis, reductive ozonolysis is mentioned in which 1 of the mole is aldehyde. So based on that also we can give this conclusion. So here the double bond breaks. So we are going to have a formaldehyde. Then what is B? B should be having the respective 3 oxygens are supposed to be present. And at the same time, it is very well mentioned that it gives a tolerance reagent test. So automatically that makes it what? It has to be an aldehyde. It has to be an aldehyde. So the structure, probable structure of B should be with a benzene ring and the side chain to be CH2, CHO. And here we do have an acetal ring present. Okay. So that is what we have for the compound. So that is B. Then let's take up the next reaction what we have been given. The compound A on oxidation with KMnO4 gives a compound C which does not give color with FeCl₃. So automatically it makes it a carboxylic acid. So what are we going to have here? we are going to have an carboxylic acid, COOH. The rest of the molecule remains the same. Now here is a reaction happening with the H side, wherein when the acetal bond has to be broken, it breaks in such a way that there is a diol generated, and the carbon which is present here, this carbon here, is converted into a formaldehyde on reflex with concentrated HI. So this is how the reaction is proceeding. I hope it is clear. Thank you.